We want to be using nodal analysis or node voltage to solve this circuit. The first thing you want to do is identify and label all the nodes in the circuit. Number 2, choose a reference node, the ground, and set the voltage equal to 0. Pick one of the nodes to start with, apply KCL to that node, and then repeat the steps 4, and then solve the system of equations. So in this example, the first thing we want to do is identify and label all the nodes in the circuit. We are already given V1, V2, and because we're trying to solve V0, I will say that this is V3. The next thing we want to do is have a point of reference node, ground, where we set V equal to 0. So since this is the negative terminal over here and this is the positive terminal, for convenience, I will say that this is node A, node B, node C, node D. Since there is no components in between A and C, I mean A and B, A equals B, there's no components between B and C, B equals C. No components between D and C, D equals C. And because I want this to be my ground, because this is a negative terminal, it's just easier, not always what you want to do. I'm going to say that this is equal to 0 volts. So everything is equal to 0 volts. Now we want to start writing our equations. We want to pick one of the nodes to start with. I'm going to pick V1, just because it's the first. So as did in the steps before, if there is a current going towards the node that you picked, it will be a negative number, negative 12. If it's going away, this is moving towards negative 12, this is going away from V1, that is a positive value. And next we want to find a current. We're going to use KCL in this equation for this, and since our node of reference is V1 for this, it's going to be, since we're going to use Ohm's law for the current, V equals IR, I equals V over R, and like it's delta V, right? Like from this node to this node, it's going to be delta V, plus V1 minus 0 over 3 for that. And since we're going to do this node now for the 6 kiloohms, again, we're going to start off with V1 because that's the node we're focusing on. V1 minus V2 over 6 equals 0. This is our first KCL equation. Now I will be focusing on V2. So once again, since we see this going towards V2, the current, that will be a negative 2. Next, I want to focus on the current for the 6 kiloohm going down. Since again, this is bottom 0 volts, because that's what we set our ground as. This is going to be plus V2 minus 0 over 6. So since V2 is our reference for this, the current will be going this way for this equation. So our equation will be V2 minus V1 over 6. And the last one, solving for V3, got the 2 kiloohm one. Our current will be going that way from V2. So our equation will be plus V2 minus V3 over 2 equals 0. This is our second equation. Focusing on this node V3, our final node, we will be finding the current in this branch. Again, with respect to V3, V3 minus V2 over 2. And since this is ground, since all these bottoms are equal the same, this will be plus V3 minus 0 over 1 equals 0. That is our final KCL equation. And now, solving these equations, we will get V1 over 3 plus V1 over 3 equals V1 over 2, negative V1 over 6, V2 over 6, sorry, plus 0 V3 equals 10. For this equation, we will get negative V1 over 6 plus V2 over 6 plus V2 over 3 plus V2 over 6, which equals 5 over 6 V2, and then minus V2 V3 over 2 equals 2. And then for this equation, we get 0b1 plus negative b3 over 2, and then plus b3 over 2 plus b3 over 1, which equals 3 over 2 equals 0. And then plugging these in solving the system of equations, you can use a matrix, whatever you choose, you will end up getting b1 to be 9091. Your v2 will be 8.7273, and your v3 will be 2.9091. Using those values, you see that v naught over here, remember positive minus negative is equal to v3 minus 0 volts. So v naught equals v3, which equals 2.0901 volts. So for this next circuit, we will be using the same steps that I showed in the beginning of this video. First, we want to identify and label all the nodes in the circuit. So I can see that there is a current going towards this node. There is a current going towards this node. And there's a resistor here, a current source here, and another resistor here. So I will say that my V1 is most likely going to be here. And since there's no component between these two nodes, this is also V1. Same thing with here, there's a component here, a component here, a component here, and a component here. So I will say that my V2 will most likely have to be here. And since they are the same, since they have no components in between them, they will be the same node. And the next step, step 2, was to pick a ground, or a point where V naught is equal to 0, or V is equal to 0. So I will say that since there is nothing here, by personal preference, there's no components in between any of these nodes. By personal preference, I will say that this is equal to 0, equal to 0, equal to 0, and equal to 0. So the node I want to be starting my first equation with will be V1. Once again, since there is a current heading towards V1, that will be negative 1 milliamp. Since there is a current heading away from V1, that will be negative 2 milliamps. Sorry, positive 2 milliamps. Away is positive, towards is negative. And to find the current in this node, with respect to V1, because this is the V1 equation, we'll be saying that V1 minus V2 over 2 is our current. And finding this one, again, since this is all 0, we will get plus V1 minus 0 over 8 equals 0. That's our first equation. Now focusing on V2, our second node, I usually get currents first. There is a current heading towards V2. That will be a negative 2 milliamps. The current going from here to here for the 3 kiloohms. And now we'll be focusing on the current on the 3 kiloohms, since it's from respect to V2, it's going to be V2 minus 0 over 3 volts. And since, again, this is ground as well, the current going from V2 to ground will be plus V2 minus 0 over 6. And lastly, the current going from here to here will be plus V2 minus V1 over 2 equals 0. And now solving this equation, we get V1 over 2 plus V1 over 8, which equals 5 over 8 V1 plus negative V2 over 2 equals negative 1. And this one, we get negative V1 over 2 plus V3 over 3 plus, sorry, V2 over 3 plus V2 over 6 plus V2 over 2, we get V2, just 1 V2, which equals 2. And with this, we get our V1 to equal 0 volts, and our V2 to equal 2 volts. And since we're trying to find the current in this branch, our equation will be V2 minus 0 over 6. And we plug in V2, so 2 minus 0 over 6. Our current is 1 over 3 milliamps. And lastly, to solve a problem like this, where there is a voltage source, since it's the positive terminal and this is the negative terminal, I would say that this over here is 12 volts. And since this is the negative terminal and this is the positive terminal, I would say that this over here is negative 6 volts. If I say that this is V1, and I'm trying to solve for V1, I know the problem solves for I0. I don't care about that right now. The way we would solve this is current going this way, V1 minus negative 6 volts over 1 plus V1 minus 12 volts over 2. Current is going away from V1 plus 2 milliamps equals 0. We don't care about this because this doesn't directly touch V1. The node doesn't directly touch V1. And solving this, we get 3 over 2 V1 equals negative 2, V1 equals negative 4 over 3 volts.